In this class, we are going to learn about the factory design pattern. The factory design pattern is so commonly used nowadays as a part of modern frameworks and libraries that we don't really realize that it's a unique design pattern of its own. Our mind automatically thinks of using a factory when we have multiple objects to create. Java libraries like Swing, JavaFX, and a multitude of other frameworks have just made it the norm to use factories when we want multiple objects of similar types. So, what is the factory pattern? Let's do a quick Google search and see what we get. Maybe we'll get a Wikipedia article. Here is what Tutorials Point, which has a lot of nice explanations of the different designs patterns, has to say. The factory design pattern is a type of creational pattern because this specifies a way in which we can create an object. The whole idea of the factory pattern is that there are a whole variety of objects you may need to create. The creation logic should be hidden from the users of the factory. We should make it as simple as possible for the factory users to create objects and not expose all the internal details. Any client which uses this factory will get an instance of an object which adheres to a common interface. The client does not need to know what object has been instantiated. All it needs to know is that the interface is available for its use. Let's see an example over here. Here we have shape, a very common interface we are all familiar with, and circle, square, and rectangles are types of shape. See the shape factory? We can ask the shape factory, our code can ask a shape factory to return a shape, say circle, rectangle, or square, but we don't need to know the implementation details. We just pass the correct arguments in, and shape factory will make sure that it instantiates and returns the correct shape to us. This is what the factory design pattern gives us. Let's take a real-world example of when the factory pattern can be useful to us. Say we are writing an application that pulls in data from a database and then does stuff with it. Maybe you're generating reports, maybe you're running analysis and insights. This is a pretty typical application any company might want to write. Really common use case. Now let's say that the company that you're working in, that's our company, uses MS SQL Server as its database. MS SQL Server has worked fine so far, but right now we are in the process of moving to Oracle. Both of these are good databases. We use MS SQL, there might be reasons to move to Oracle. The most common reason typically is each time a new CIO takes over. So again, a common use case, we are using MS SQL, we want to move to Oracle. Now this can be a pretty painful thing to do. So how do you minimize the pain associated with the change in database servers? How do you write your code so that your entire team can move from MS SQL to Oracle with the minimum amount of pain and the minimum amount of disruption? It's not a trick question. What you'll do in this case is to use the factory pattern. The factory pattern is built for such use cases. Now, if you really sit down and think about how to write this application, which can easily withstand the change in databases without causing the team a lot of pain, if you think about it, the way our code interacts with the database is completely independent of what database it uses. Databases tend to follow a very standard pattern, tend to respond to very standard commands with a few exceptions or a few differences between them, which can be smoothed over without the client using the database knowing of it. Typically, we would connect to the database and use that connection to run database commands. These commands could be query tables, to modify tables, to add stuff to the database, etc. etc. These queries tend to be pretty similar across databases, if not exactly the same. Now, we've decided that we are moving from MS SQL to Oracle. What changes when we move from between these two databases? Merely the way in which we connect or run queries. the entire connection setup, all the preliminaries to connect to the database will change, and how we execute the queries on them will change. So we are independent of what database we run our queries on. So how do we take advantage of this? What we can do is to create an interface. Let's call it iDatabase, which has all the methods which are common across all databases. So iDatabase will have all the methods that we run and which are common to all databases. Then we have to have a way which reflects the manner in which we connect and run queries. This is an implementation detail. So we can create two database classes, one for MS SQL and the other for Oracle. And each of these classes can implement the iDatabase interface. So the actual technicality of how the connections are made will be embedded in the classes and not the interface. This means the interface will do what it's supposed to, specify what can be achieved using the interface. And the classes will do what they're supposed to, specify how to achieve those contracts which the interface has made with the client using that interface. This is how we split it up. Now that we have the iDatabase interface and the two different implementations, in our client code, we'll have a single member variable of type iDatabase. Remember, it's important not to reference the implementations directly. We're only interested in the interface and all the methods that this interface exposes. So we have an iDatabase, a single member variable. Now, one important thing to ensure is the rest of the code, other than the part which instantiates the class which goes into this member variable, only deals with iDatabase. The rest of the code should have no idea that there can be multiple databases which implement the iDatabase interface. It's important for the rest of the code to be completely abstracted from the knowledge of having two database implementations. Now, all our original code pre-switchover, this iDatabase member variable will hold an instance of an MS SQL database object. That MS SQL database object, which is an implementation and contains and wraps all the implementation details of working with an MS SQL database, will be held in this iDatabase member variable. After we've switched over, post switchover, we update this member variable so it holds an Oracle database object. So each of these implement the iDatabase interface. So they can be exchanged one for another without the client code ever being wiser. So remember, pre-switchover, this variable will hold the MS SQL database object, and post-switchover, it will be updated to hold an Oracle database object. Now, there are several ways of doing this. There is a smart way and multitude of dumb ways. And the smart way is, of course, to use the factory pattern. So let's see how we can use the factory pattern to help us make this switchover smooth. But before that, we'll look at a couple of dumb ways of achieving this, and we'll talk about why they are dumb. So we could have a very naive implementation which basically uses the iDatabase interface but not the factory. So we'd have database is equal to new MS SQL database. This is how our code would look before we switched over. And after switchover, we'd simply go in and change this one line of code to say database is equal to new Oracle database. Okay, why is this wrong? What's wrong with it? On the face of it, there's nothing really wrong with this code. We are changing the implementations. We are using an interface, which is the right thing to do. We don't want to be tied to the implementation details of either MS SQL or Oracle. We want to deal with an interface, and this code is doing it. What is wrong with it? Why is this not a great way of solving this problem? Let's think a little deeper of what it means to make the change in this manner. This means that the switchover involves modifying code in the application that you've built, recompiling this application, and then re-releasing this into production. Now, for a small system, this is not a big deal, and you'll just imagine that you'll just do it and forget about it. However, what about those large, complicated systems which exist out there? And in all likelihood, the system that you've built is large and complicated. Production systems can be extremely complex, have many moving parts. It may not be the right thing to release your code at any point in time. There may be subtler issues. Maybe other systems fail. You have to have all of them working together in order to make a production release. And simply switching over the database and making a production release for that, that's not a good thing to do. Let's see if we can decouple ourselves from a release to production for a simple database change. Finally, let's see the smart way or the factory pattern. You can simply say iDatabase, the database variable which is holding the implementations, equal to database factory.get database. You're hiding the creation details behind this database factory class. So you're simply asking a factory object to give you the correct type of database object, and it magically knows how to. Now, the obvious question here is, what is this factory object and how does it actually know what is the right type of object to instantiate at any point in time? These are all good questions, and that's exactly what we're going to answer right now. Now, typically, what this factory object will do under the covers, unknown to the client code, is read in the name of the class which has to instantiate from a config file. At any point in time, the factory object knows that the right class to instantiate by reading it in from a config file, and then use reflection to instantiate the correct object. There's a lot going on in this sentence, and hopefully you're familiar with reflection. We'll talk about it shortly if you're not. But the use of a config file and the use of reflection is what will help us solve this problem without releasing code to production. So, what is a config file? A config file is simply a text file. This specifies key value pairs which are used as inputs to an application. The interesting thing about these key value pairs are they can be modified at runtime. The application can be hosted in production on some server, and you can simply change these key value pairs at runtime so that the application changes its behavior accordingly. Config files are so commonly used that any serious production system will have at least one config file. The whole idea of using configurations is to basically decouple things which can be specified after something has been launched to production. The awesome thing about a config file is changing a config file does not need code to be changed and re-released. So it's kind of dynamic or runtime behavior which you can affect on a production system without a new release.